Hey, welcome to Types of Reactions and some examples. We're going to jump right into it so we can get started on understanding how these all work. So these are some patterns that can be used to determine the products of simple chemical reactions. There's many others as you go throughout chem, but we're just looking at a few to give us an idea of how to predict products. So first we have synthesis. The component that we're looking at is that it's two elements combining to make one compound. That's what these letters represent. Now, if we made it with water, we'd make a hydroxide. That's that polyatomic ion OH-. So let's take a brief example of looking at how we can approach these to determine our correct products. All right, so we did these a little while ago, in which what we're going to try to do is we have to have the metal first, like aluminum. And that's going to be with the nonmetal nitrogen. Now this is a 3+ ion, 3- ion. And you might remember that if you have one of each and they have the same number of opposite charge, then that means we just need one of each. So our correct compound will be AlN. That is our correct chemical compound. Now down here, we again want to put the metal first, so that would be Na. Then the nonmetal, chlorine. And you see I don't add the subscript. It's diatomic as an element, not as an ion. This one's 1-, this one's 1+. Remember, these followed patterns, so you should be pretty comfortable with those now, or still look them up. We can see equal and opposite charge, so we have just NaCl. Oh, big C. So NaCl would be our compound here. We're not going to balance it with coefficients. And if we wanted to look at evidence of a chemical reaction, we would look at there's a color change, seeing this from silver or silverish gray to yellow to making it white. So that would be evidence of a chemical reaction. Next, we've got decomposition. So decomposition takes a compound and breaks it apart into its separate elements. So first we have potassium bromide, and so that would be breaking it into potassium, no subscript because they are singular, and then bromine. And bromine, you might remember, is one of our diatomics, so Br2. As we come here, tin 2 oxide, well, S. Tin is just a metal, so it's singular by itself. And oxygen is one of our diatomics, is O2. You can see it doesn't matter if it had a single before. By itself as an element, it's going to be O2. So these are quite simple, or you'd have to memorize all the different spots. So we're not going to be testing on this one, just wanted to show you this here. Now, as far as evidence of a chemical reaction, there's a color change, such as a rotting apple, and there would be a gas forming. Now, you know you can't smell the picture, but think of decomposing stuff. They are also always very stinky and smelly because new gases are being formed. So let's take a look at our next example. Single replacement. This is where things start to get a little more challenging. So we start off with an element, and you can see a compound, making a new compound, and kind of removing an element from there. Now we can see the position of this A and B switch, and A and B would be a metal ion. Likewise, we can switch the non-metal ion, which would come second in an ionic compound, creating this part here. So we first want to look at, we have calcium and copper. Those are both metals, so those are going to switch places. So we know the copper is going to be booted out. That's just by itself. Now we need to see what's the correct compound between calcium and nitrate. So we've got calcium with its 2+, and then NO3, that's one of our polyatomic ions, that's a 1-. So crossing the charges down, we should get 2 of the nitrates and only 1 of the calciums. So calcium nitrate. We get 2 of those. All right. Now we come down to here, we have an ionic compound, and we have this being a nonmetal. So that's going to replace the nonmetal here. So I know sulfur will be kicked out all by itself. And then we need to see what happens with nickel and phosphorus. Now nickel is one of our transition metals that does not have a unique charge, so we need to determine what the charge is. Sulfur is 2 minus. That means the nickel has to be 2 plus in order to cancel it out. So now I can do my crisscross over here. So nickel with its 2 plus, phosphorus with its 3 minus, crossing down the charges. And I'd get my Ni with 3 of those, and phosphorus with 2 of those. As far as looking at the evidence of chemical reaction, it looks like a spring, but it's actually some copper wire that's actually changing the color, as this was once clear, now is blue, and changing from the coppery color to this gray mesh-like stuff. We're going to continue this on with the double replacement, probably the most challenging, and finally, one of the easier ones, combustion.